In this unit, we're going to study two different types of functions. We're going to study absolute value functions and we're going to study reciprocal functions, but we're going to start with absolute value functions. Some of you have seen absolute value before. First thing I want you to note is that absolute value has what are called absolute value bars. It's these bars that are around this 6 here. So this is read as the absolute value of 6 is 6. And the absolute value of -6 is also 6. And you may be wondering, well, why does the absolute value always give us a positive answer? And the explanation for that is right here. That the absolute value of a number is the distance. This is the key thing. It's the distance the number is from 0 on the number line. So when you measure distance, you always measure distance in positive quantities. So if we look at 6, well, 6 has a distance of 6 units from 0. If we look at -6, -6 has a distance of 6 units from 0. So that's why the answers are always positive. So the absolute value of any number will never be a negative. Never, ever, 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 ever. So if we quickly look down at a few questions here related to absolute value, the absolute value of 3 is just 3. The absolute value of -3 is still positive 3. Careful here. This is the absolute value of 8, and this has a negative in front of it. So this is like saying -1 times the absolute value of 8. So -1 times 8 is going to give us -8, but the only part inside the absolute value bars is this 8 here. Same thing in the next question. This is like saying -1 times the absolute value of -8. Well, the absolute value of -8 is positive 8. And when you times that by the -1 in front, you are going to get the answer -8. Here, we have the absolute value of -7, which is 7, plus the absolute value of 7, which is 7, and we get an answer of 14. 1 minus 5 is -4, and the absolute value of -4 is 4. And in our last question, here we have the negative of the square root of 81. Well, the square root of 81 is 9. So we have the absolute value of -9, which is 9, times -1, which is in front, to give us an answer of -9. So those are just a few absolute value questions, just the basics of absolute value. Now, most of what we're going to look at related to absolute value is going to be related to absolute value functions. So we're going to look at graphs, we're going to look at equations and how those things are solved. So the next part of this lesson is definitely going to be focused on the graph portion of absolute values. So what we're going to investigate is we're going to investigate what does the graph of an absolute value function look like and how does it compare to other graphs that are out there. So if we look at the left-hand side here, it asks us to graph y equals x and y equals -x. Well, if we graph y equals x, if I pick some values for x, like -2, -1, 0, 1, 2, and I plug these in, this says every y value is equal to every x value. Well, if I plug -2 in for x, I get y to be -2. If I plug -1 in for x, I get y to be -1. So y is actually exactly the same as x. So if I graph this, I get -2 and -2, -1 and -1, 0 and 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. So if I draw that in, if I actually use a ruler and make a nice straight line, that's what y equals x is going to look like. Now it also wants us to graph y equals -x. Well, if I do the same thing for y equals -x, -2, -1, 0, 1, 2, what this is saying is I want to take the negative of the x value. Well, if I plug -2 in here and take the negative of it, meaning I change the sign, it becomes +2. Negative 1 becomes positive 1. 0 stays the same. 1 becomes negative 1, and 2 becomes negative 2. So essentially what you're doing is you're changing the sign of the x values to get the y values. So we get negative 2 and 2, negative 1 and 1, 0, 1 and negative 1, 2 and negative 2, 3 and negative 3, etc. So we actually get this line right here that I'm going to draw in. So this left-hand line is going to be y equals negative x, and this right-hand line is going to be y equals x. Now, what they want us to do on the right-hand side is they want us to graph y equals the absolute value of x. So they've made a table of values here. If I take the absolute value of negative 5, it's 5, 4, 3, 2, 1, 0, and 1, 2, 3, 4, 5. Remember, absolute values of any values are always positive. So I get negative 5 and 5, negative 4 and 4, negative 3 and 3, negative 2 and 2, negative 1 and 1, 0, and then it keeps going back up like this. So if I actually graph the absolute value function, it looks like a V. Okay? Now, if we look at the next part, it says explain the similarities and the differences between these two sets of graphs. Well, if you look at this, if we look at the top half of the absolute value graph, it's exactly the same as the top half of this left-hand graph of y equals x. So if we look at this, these are y values that are positive, and these are y values that are positive. So when y is greater than or equal to 0, the graphs are the same. Exactly. Now, when y is less than or equal to 0, the graph of y equals absolute value of x has no points on it. If we look at this negative portion here, and that makes sense, we have no negative values when we do absolute value. Absolute value always gives us a positive answer. So because absolute value gives us a positive answer, there's no graph down here, it's undefined. We do have a graph in this section though, so that's a difference. The similarities are on top and the differences are on the bottom. Now, the next thing it wants us to look at is it wants us to look at the graph of y equals the absolute value of x. So this graph here, and it wants to state the equation of the line in quadrant 1. Well, quadrant 1 is this quadrant in the upper right corner. Well, this line here is exactly the same as the same line in the left-hand graph. So in quadrant 1, the absolute value graph is made up of the line y equals x. If we go to quadrant 2, this line or this portion of the absolute value graph is sloping downward, just like this downward sloping portion in our left-hand graph. So the equation of that portion is y equals negative x in quadrant 2. So basically what they're telling us is that this graph of the absolute value function is actually made up of two pieces. It's made up of the right-hand portion, which is the function y equals x, and the left-hand portion, which is made up of the function y equals negative x. So what ends up happening is we can actually express f of x equals the absolute value of x as what's called a piecewise function. We can express it as two different functions or two different graphs. So if x is greater than or equal to 0, that's the right-hand portion of this graph. That's where x has values greater than or equal to 0. This function is made up of f of x equals x. That's that function in the first quadrant. If x is less than 0, that's where we're looking at the second quadrant. All these x values are less than 0. Our graph is made up of the function negative x. So we've essentially taken these two functions and we've expressed it as a piecewise function. We've told whoever's looking at this that this graph is made up of two different functions or two different parts. That's how that's constructed. Okay, let's look at another absolute value function and how it compares to some other graphs that are out there. So we're going to do something very, very similar. What we're going to look at is we're going to look at x minus 3 and we're going to look at the negative of x minus 3. So we're going to look at those two functions first of all, and we're going to make tables of values for those two functions, and we're going to graph them. So if we take negative 4 minus 3, that gives us negative 7. Negative 3 minus 3 is negative 6. Negative 2 minus 3 is negative 5. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Just keeps increasing. If I plot this particular graph here, negative 4 and negative 7 is here, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. It gives us a straight line like this. So I'm going to draw that straight line in. Now, if we do the other portion of this, if we take negative 4 minus 3, that's negative 7. But if you take the negative of negative 7, it's going to give us positive 7. Same thing here, negative 3 minus 3 is negative 6, and you take the negative of negative 6, it's going to be 6. So this will be 5, 4, 3, 2, 1, 0. Now this will end up being negative 1 and negative 2 because 4 minus 3 is 1, and when we take the negative of it, it gives us negative 1. So if we start graphing this, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2. We again get two intersecting lines, one sloping upward and one sloping downward. Now, if we actually want to graph the absolute value of x minus 3, well, negative 5 minus 3 is negative 8, but you take the absolute value and you get 8. Negative 4 minus 3 is negative 7, and you take the absolute value as 7, then 6, then 5, 4, 3, 2, 1, 0, and then we're going to get our negative 1 and our negative 2. Okay, so negative 5 and 8, negative 4 and 7, 6, 5, 4, 3, 2, 1, 0. Hold on. This should be positive 1 and positive 2 because 4 minus 3 is 1 and 5 minus 3 is 2. So this should go back up like this. So if we draw this in, our absolute value function looks like this. So again, if we compare this, this absolute value function looks like the top portion of this graph here. And this right-hand line is y equals x minus 3, and this left-hand line is y equals the negative of x minus 3. So if we look at writing this as a piecewise function, we look at this portion down here. When I have the line x minus 3, that's this line here on my absolute value function, that occurs if x is greater than or equal to 3. So from 3 to the right, I get this particular situation. If x is less than 3, I'm going to get this negative situation. So the 2 points or 2 lines that form this are our x minus 3 and our negative x minus 3, and the breaking point is where our x-intercept is. That's where it divides this graph in half, and that's where we change between the two functions that create our piecewise function. So on the next page, it asks us to explain how the equation of the second piece is determined from the equation of the first piece. So basically what they're saying is, if I have something like y equals x minus 3, how do I use this equation to get the equation of the second piece? Well, basically what you do is you take the negative of the first piece to create the second piece. So in this case, the second piece is y equals, and if we take the negative of x minus 3, that's the negative of x minus 3. That's how we create the second piece of our graph. The first piece of our graph is created by this, and the second piece is created by taking the negative. So the next question says, explain algebraically, without using a graph, how the domain for each piece could be determined. Well, basically, the x-intercept divides our graph into two pieces. So if we go back to the graph that we have, and I talked about this a little bit, this x-intercept here divides our graph into two pieces, a right portion and a left portion. So with pieces being x is greater than or equal to p and x is less than p, where p is our x-intercept. So this value here, whatever it happens to be our x-intercept, that tells us what we're going to be greater than or equal to and less than or equal to when we write a piecewise function. So some of you are going, huh? What? So I'm going to take what we've written here, and I'm actually going to use it to write a couple of piecewise functions down here. So if we look at f of x equals the absolute value of 3x plus 2, that's the same as saying y equals 3x plus 2. That's our starting function. So when we go to write a piecewise function, we write f of x equals, and we use our curly brackets. Now, the first function that's going to define our absolute value function is 3x plus 2. And the second function that's going to divide our piecewise function is the negative of this particular thing. Now what we have to do to determine when x is greater than something and when x is less than something is we have to solve for our x-intercept here. So we have to take 3x plus 2 and equate it to 0, and we need to solve for x. And when you solve for x, you're going to find out that the x-intercept is at negative 2/3. So our first function is greater than or equal to our x-intercept, and our second function is less than our x-intercept. That's going to give us our two pieces, the portion going to the right and up, and this is the portion going to the left and up. So basically what you do to write a piecewise function is you take your original function, you write it down, and you write the negative of it. Then you find the x-intercepts, and you write your domain restrictions for this. So we're going to do the same thing for the next function. Our function here is y equals 4 minus x. So when we write our piecewise function, we're going to have 4 minus x, and we're going to have the negative of 4 minus x. Now if we solve this, if we take 4 minus x and we equate it to 0, we get negative x equals negative 4, so we get x to be 4. So when we're actually going to solve this and write our piecewise function, we're going to get that x is greater than or equal to 4 and x is less than 4 for our restrictions on our domain. And there we go.